Okay, so hello everyone, welcome. Can you hear me? Hello. Okay, can you hear me? Okay, thank you. Okay, just you're waiting some 1 minute, then we'll start. Okay, so now we'll start our today's session. So hello everyone, welcome. So basically today is our third number of class, and we already completed our first and second class. I hope all of you already get the recorded class as well also get the practice code. And I already put the some assignment. You also try to do that. Okay. So basically today is our third number of class. Today we will discuss about the different types of remote sensing analysis using Google Earth Engine platform. Okay. So let's go. Just I simply share my screen. Can you see my screen now? Okay, thank you. Okay, so let's. So basically today I will try to discuss about our third day's topic, mainly calculating any indices from satellite images using Landsat or Sentinel imagery, as well as we also try to discuss about the filtering and displaying the satellite images, mainly Sentinel-2, and monitor the NDWI or NDVI. And basically in this time we also try to discuss about the water logging monitoring, okay, using Google Earth Engine platform, remote sensing based assessment of water logging monitor using Google Earth Engine. In this time we also try to discuss about that. Then how to extract the water body using the thresholding. Okay, we can easily apply the different types of thresholding technique and extract the different types of feature from satellite images. So this thing I will try to discuss. And we try to discuss about that time series chart. Okay, previous class I tried to discuss about that how we can easily monitor the ready-made time series chart, how we can make the time series chart for the ready-made data set. But in this time, also try to discuss about that how we can easily make the time series chart for unready-made data set. Okay. Then how to export any shapefile from Google Earth Engine and how to add the gradient, legend, and title on Google Earth Engine, and NWI calculate from MODIS or Landsat data, mainly water surface. So let's go. So first of all, I try to simply open my slide. So in this time, just I open my code editor. And in this time, suppose I want to work for the Sentinel-2 satellite imagery, how I can filter. So just I simply click on the browse data catalog. So now you can see here it's the Sentinel. So just click on the Sentinel. So here I find out all of those Sentinel image collection. Sentinel-1, Sentinel-2, Sentinel-3, Sentinel-5, all of those. I simply click on the Sentinel-2 multispectral instrument, and then further I want to work for, suppose, surface reflectance. So here you can say I can get all of those information about this image collection. We can got this image from year of 2017 to 2024, this time period. And this is the dataset provider, European Union, ES Copernicus. And it's a unique ID about this dataset, as well as we also get all of those band, okay, as well as also get the scale about that. Okay, we can easily use this type of scale and for get the proper value of wavelength. And we can get the description about that. Band 1 is the aerosol, band 2 blue, then green, red. Okay, all of those band we can easily get from here. So in this time, I just simply copy this snippet and then paste on my code editor. Okay, so it's an image collection. So this image collection, I just need to store it in a variable. So just give a variable name. Suppose I put the variable name is a, you can put any name as a variable. Suppose I put this name as a, suppose, Sentinel 2. Okay, so in this time I simply put this name. This is the variable name, and this variable is stored this image collection. Okay, so now this image collection I need to filter for 2 time period. One is rainy season, another is dry season. Okay, so this image collection I need to filter for 2 seasons, rainy season and dry season, and then monitor the suppose waterlogging for the 2 time period. Okay, so in this time, this is my image collection. This image collection is stored in a variable. And now what is my region of interest? In this time, suppose my region of interest is, suppose, Dhaka city. Okay, I want to observe what's the condition of Dhaka city in rainy season for waterlogging, where we find out the waterlogging place. We can monitor using the remote sensing technique and identify this type of place is the waterlogging. So for that, I just simply import the Dhaka city boundary shape file. Suppose I already imported the Dhaka city boundary shape file. I simply click on here, it imported, and it shows the default name as a table. If you want, you can easily change it. I put the name, suppose, as a RY. Okay, so now I input my image collection and also import my study area. So now I just need to filter this image collection for rainy season as well as also dry season. Okay, I compare the 2 time period, rainy season and dry season. So that's why in this time, this image collection I just filter into dry season and rainy season. So how I can filter? Previous class I already discussed about the lot of function for filtering. In this time, we are also use the same function for filtering. Suppose I want to filter, I just write the comment, filter image collection for, suppose, dry season. So how I can filter? Basically, when you want to filter the image collection, here we need the 3 factor. One factor for the where you need this image. Second factor, how, and third factor is that when. Okay, so in this time I already defined, suppose, where I need this image in Dhaka city. Okay, so this is my where, and how, suppose I need the less than 1% cloud cover image. Okay, and then when I need this image, I need this image for dry season. According to these 3 condition, where I need this image, Dhaka city, I need this image, which image is the less than 1% cloud cover, and I need the image for the dry season. So in this time, I just simply use these 3 condition and then filter this image collection for dry season. So let's go. Just give a variable name. Suppose I put the variable name is any name. Suppose dry. Suppose dry image. You can put any name. I put this name is a dry image. And now equal sign. I call my collection sentinel2 and paste here. Okay, this collection I need for Dhaka city. So just I use a function, this function called filter bounds function. Basically, this function help you to filter your boundary. Okay, it intersect the whole collection with your study area. In this time, your study area mainly RY, Dhaka city. Just give the variable name RY. Okay, done. After that, how you need this image? I need this image less than 1% cloud cover. Okay, suppose it's my condition. So for that, I just simply use a function filter metadata. Okay, and then put the image properties name. So we can easily get the image properties from here. You can see the image properties. Suppose cloud pixel percentage less than 1%. I simply copy the properties name and further paste here, and then give the name. Suppose less than, it's the operator, less than, and set 1. Okay, and then when you need this image, I need this image suppose for dry season in year of 2023 or 22, any time period for dry season. So put the filter date such as year of 2020. Suppose 1st January from year of 2023. Suppose 04 April. Suppose 30. Okay, I consider this time period as a dry season for Bangladesh. Okay, so now further in this time, suppose I just simply use a median function. I take the median composite, all of this image collection, and then it clip with my study area. Suppose clip with my study area mainly RY. So now display this image. So I can easily use a function map.add layer function for visualize this image. So map.add layer, and mainly I want to show the dry image. Simply copy and paste here. So now click to the run. You can see it not focus the center of this boundary. So for focus the center of this boundary, we are using a function. This function called map.center object. In this time, my object, suppose object can be a dry image. If you want, you can also use. Suppose I put the dry image. It also okay, no problem. Okay, now it focus on this image. Okay, so now click to the run. In this time, you can see it focus on the image, but not zoom. Suppose I put the zoom level, suppose 10, and then click to the run. So now, okay, I think, let me check. I think it's better to use here the shape file. Suppose I simply copy the shape file and object, suppose the shape file, now click to the run. Okay, so it's perfect. Okay, so now you are just use here the object as a shapefile boundary. Okay, in this time I already put the shapefile boundary in the ROI. So simply put here the ROI. So then it will directly focus on this boundary. So now we can get this type of image for year of 2020 dry season. So now further, I just simply add the visualization. Suppose click on here, and then put here that band 4. Suppose band 3 and band 2, and further custom stressing such as 98%. You can see here in this time we can get this type of value 508, 1686. In this time it shows this type of value because I don't multiply with my scale factor. Okay, so in this time you are just simply multiply with a scale factor. So just I simply use a multiply function. Multiply, basically what is my scale factor for all of those band. You can see all of those band is the same scale, 0.001. So just I simply copy the value 0.001 and then multiply in here. So now we are also get the proper value. So you can see it working. Okay, so now I am stressing again. So simply click on here, and now I am to show at the suppose red band, then blue band, sorry, green and blue. Okay, RGB color, red, green and blue. Stress 98%, and further just apply. So now we are also get this image for dry season in year of 2020. We can get this dry season image collection. We can get the very clear satellite image. You can see there is no cloud. All of those things will be very clear. We can easily get the very clear satellite images. Okay, so now we can easily use this image for your different types of analysis. Okay, so in this time I just simply click on the import option. You can see the import, and a new line of code will be added. Simply copy this variable name and further paste after the object name. So simply paste after the object name, and then I put the layer name, suppose dry image. So now click to the run. So now this visualization is set with your code. So now we can get this image for the dry season. So now I need this image for the suppose rainy season. Okay. So then we are easily compare the two time period, and then we can easily identify or monitor the water logging condition. Okay, in the rainy season. Okay. So in this time, I just use the same code for making the rainy season condition. So just I simply copy the same things from here. Okay, just simply change the date, and then further I show this layer. So paste here. So in this time I simply put here, suppose say the time period, suppose 5, and suppose put here the suppose 10 October. Okay, this time period I simply put in here. Okay, sorry, we are considering only for the 1 year. Sorry, it's the 2020. Okay, 2020 January to April. Okay, also 2020 May to October. Okay, just put here the 2020. We consider for 1 year. Okay, and then further we have changed the name. Suppose it's a rainy season or rainy image, and then I want to show this image in here. Okay, so just without it I try to show this layer. I say suppose this image for suppose rain. In this time it added the image for rainy season. Okay, so what's the problem? If one image has no band, must have no bands for 0 and 1. Okay, let me check. Try to add the later. Okay, in this time, okay. So in this time, okay, if you want, you can also check the suppose how many image collection is available. Suppose I am to check. I think this time there is no image with the less than 1% image is not available. So for that, first we try to check it. How many images is available? So print this rainy image, simply copy and paste, then use the size function for checking how many image collection is available or not. Basically, rainy season is very difficult to find out. The lower cloud covered image is very difficult to find out. In this time, we can get, you can see 0%, zero, okay, zero image. So this condition for the Dhaka city, mainly rainy season, we don't find any kind of satellite image which is less than 1% cloud pixel. There is no image. So that's why, how can I do that? Simply increase the number. Okay, increase the number. Suppose I put here the 2%. Now I check what happened for the 2%. Less than 2% is available or not. We can check. Also, there is no image. Suppose I check about that less than 5%. Also, in this way, we can get the 2 images. Okay, you can see sometime you work, but sometime when you want to work with the rainy season, you don't find out the image. It show the zero image. Okay, then it not loaded the layer. So then you have to check according to this condition if there is image is available or not. In this time I check 1%, less than 1% cloud pixel percentage image is not available. So that's why I just increase the value. I consider less than 5%. Okay, I consider less than 5%, and then I find out the two images. Okay, so now I just use this two images and also multiply with my scale factor this median image. I simply multiply with this value, and finally clip with my study area. So now click to the run. I just show the layer about that. So click to the run. In this time it will be loaded. Okay, we can get this type of image. Okay, you can see. In this time I add the visualization. So click on here, and I said that suppose red band and green band, and blue band. Okay, and then find out the stress 98%. In this time it visualize the image for rainy season. In this time you can see what is the condition about the rainy season image. Rainy season image we can get the some cloud mask, we can get the some cloud. This type of cloudy pixel we can easily get in the rainy season. But dry season we are also get the very good quality image. There is no cloud or there is no haze, but you can see here in the rainy season we can get this type of cloud. Okay, you can see this type of cloud we find out here. Okay, and but dry season there is no cloud, we can get the totally fresh image. But rainy season we can get this type of cloud. Okay, so in this type this type of cloud we can easily remove from here, and we can also use here the cloud marks band function, and then we can remove this type of cloud. Okay, so for the next class I will try to discuss about that, how we can easily remove the cloud and cloud shadow or haze from the satellite images and get the very clear satellite images. For the class I will try to discuss about that. So now I want to use this image. I just simply suppose import. So simply import and then copy. Simply copy this visualization parameter and then paste here. And then further I put this name, suppose it's a rainy image. Okay, so in this time I can got the two images. One is the dry season, another is the rainy season. Okay, in this time after creating these two images, for the rainy season I need to extract the water, as well as also dry season I want to extract the water. Okay, so in this time how I can extract the water body? So basically in this time there are a lot of index we are using here. If you want you can use here the MNDWI, or if you want you can use here the AWEI, mainly automatic water extraction index, as well as if you want you can also use here the NDWI. Okay, anyone you can use, there is no problem. Okay, but it has some differentiate between the NDWI or MDWI. Okay, you can use anyone. In this time suppose I want to use here the NDWI. Okay, and then extract the water body from rainy season image and dry season image. Okay, so NDWI, I want to consider the NDWI. So first of all you have to know what is the formula about the NDWI. I simply search the NDWI formula. So basically we can get the NDWI formula. Okay, just you can see. Okay, suppose I have to use this formula, green minus near infrared divided by green plus near infrared. Okay, so I want to use this formula, and then further I want to extract the water body from rainy season image as well as also dry season image. So let's go how we can easily calculate this type of equation. So in this time it's very easy, because basically in this time it has only two bands. You can see green band and near infrared band. So when you have any equation which equation have only two bands, then we are easily use a function, this function called the normalized difference function. You can easily use, suppose normalized. So when you want to calculate any index or any indices which have only two bands, then you can easily use this function called normalized difference. Okay, and what is the argument? You can see argument is the band name. Okay, argument name is the band name. So you can put here the band name and then it will be work. So mainly you can see it computed as a first band minus second band divided by first band plus second band. Okay, so in this time I want to use this normalized difference function, and then further I want to calculate the NWI for dry season and rainy season. Compare these two things. So let's go. So I just use this function, normalized difference function. So further, what can I do? I just take a new variable, and formula is that green, suppose green minus near infrared divided by green plus near infrared. Okay, just I put the comment. So just take a variable. I put the variable in the WI dry. Okay, I want to calculate the NWI, mainly water index from the dry season image. Okay, I want to calculate that from dry season image. So what can I do? Just I simply call the dry season image. Okay, yes. So here you can see dry season image, mainly this is the dry season image. Simply copy and then paste. Okay, now this image I use and then calculate this equation. It's only for the two band, so that's why I can easily use this function. Okay, I can easily use this function. Simply copy and then paste here, and then mention the band name, mainly green and near infrared. So for the green, we can easily use that mainly B3, or we can easily check the band name also from where you can see green mainly band 3 and near infrared band mainly B8. Okay, so simply put here B3 and B8. And this function normalize difference, this function we can only use for the two band which index only have the two band, then we are easily use the normalized difference function. But some index have a lot of bands, some index have a lot of constant value, but for that you cannot use this normalized difference function. For that we have to use the another function. Okay, so I'll show you the later how we can easily calculate for the long equation such as enhanced vegetation index or soil adjusted vegetation index. So these type of things how we can easily calculate. So I'll also show you the for today's session also. In this time here you can say I can calculate the normalized difference between band 3 and band 8. So basically in this time it calculated the band 3 minus band 8 divided by band 3 plus band 8. This is the function. This function calculate this way. So now I want to show this. So just use here map dot add layer and then call the NDWI for dry. Look what happened. So in this time we can get this type of color, and if you want you can easily add here the own color combination and then check the result. Suppose I just simply click on here and then further click on the custom state 98%. And then I set the color plated. Suppose I want to show this type of color. Suppose red color where there is no water body. Suppose then get at them to show suppose this type of yellow color. Suppose get at then I want to show this type of green color. And suppose this type of things I want to show this type of color, and hide the water body and show dense water and show this type of blue color. Okay, so now I want to use this type of combination. So it show about that there is no water or very limited water, there is no water, and it show about that high density of the water as a blue color. Okay, and this is the sequence about that. So now I apply that. Okay, so we can get this type of color. Okay, we can get this type of color. You can see for the NWI map for dry season. Okay, so in this time here you can see basically in this type of region is show about that there is no water body, and this type of region show about the water. Okay, if you want to check about the value, suppose I just click on here. Here we can get suppose we can see we can get this type of value. Okay, very little. Okay, not mass. Basically, a positive value, high positive value indicating the high density of the water body, and the low positive value is identify very low amount of water body. Okay, and this type of things, suppose this type of color identify there is no water body. Okay, suppose red color. Suppose click on here. This time we can get the negative pixel result. Negative result. You can see we get the negative pixel value. Okay, so in this time it means that this type of region there is no water. It show about that I can see the negative pixel of NDWI. So it means that there is no water body. But when you click on this here, we can get this very small amount of water body. You can see we can get that very low positive value. Okay, so it's a very water indicating the water body. So let's click on here. So you can see there is no water body. Basically, negative pixel when you can got, it means that there is no water. It cannot be water. It can be vegetation. It can be barren land, or it can be build up area. But there is no vegetation and there is no water. Water body values all time will be positive. Okay. Suppose you can see we can also get the some water body also in here. I simply zoom. There you can see this is the water body. Okay. Suppose you can simply click on here, then we can easily get it the positive value. Okay, positive value identify it's a water body. Okay, okay, you can see it also water body. It show the positive value, but it's a dry season. For that, it show very small positive number. Okay, or it's a one way for importing the color, or if you want you can also add the color look like this way. Suppose I just simply randomly put here, suppose I put this make a dictionary, and then I put here the suppose mean, it will be start from suppose I put the -1, and then I put here the max, suppose +1. This is the range, and then I want to put here the plated. Suppose I put the plated such as mainly red, then put here that suppose yellow, suppose then put here that green, and suppose for water I will show suppose blue color. Okay, and also put the layer name. Suppose I put the layer name is that NDWI, it's a dry season, so put here the dry. Click on. So in this time we can get the result according to this color combination. Okay, in our NDWI map. Or if you want, you can also click on here, and then further you can easily set the color from the plated option. It is possible. In this time here you can see we get this type of result uploaded. Okay, okay, we can get this type of value when I use this type of color. And further, if you want, you can also use here the stressing. Suppose in this time it show the custom. Basically, stressing is one kind of option which maximum and minimum value when you put it show the better visualization. Okay, for this suppose in this time this model I want to put the 98% stressing. Then this value, basically this value when I put in my map mean and max, then we get the better visualization for this color combination. So click to the apply. In this time you can see what happened. In this time I can get this type of result. You can see now I can easily find out all of those things. Okay, now this map is more better than when I put at the -1 and +1. Then when I put at the -0.5 from 0.1, this range when I put, then I can get the more better map for NWI. Okay, it looks more better. You can see we can easily get the water body as a blue color. Okay, and non-water body can get this type of red color. Okay, So it can always stressing for getting the more better visualization. So in this time I want to use it, and then further I just write import. Click to the import, or if you want, you can simply copy the value. Suppose simply copy this value, and this value you can simply put it at the as a mean value, or if you want, you can simply copy the maximum value and put it at the maximum value. Okay. Also there is work. No, simply click to that. In this time, this visualization will set in your map. You can see. Now we can easily find out the water body and non-water body. You can see. Okay. So now I want to identify for the NWI map. I want to create for that rainy season. Okay. So what can I do? Same process. Just simply copy the same code and paste here. I put the name, suppose NWI rainy or rainy season, and then call the rainy season image. So you can see this is the rainy season image. I simply copy and then paste here. Okay, rainy season image, paste here. So now I want to display this layer. Simply copy and paste. Simply copy the NWI rainy season and paste here. Okay, I remove this previous value about the stressing. Okay, just I simply put, suppose I put at that -1 to +1, but I change it after stressing 98%. So I put the -1 and +1, and also put the layer name, suppose NWI or rainy season or rainy season or rainy. So now click to the run. In this time, it create this map from rainy season image, and we can get the rainy season NWI map. Okay, we can get this type of map, but in this time I want to add the more better visualization. So that's why I use the stressing. So just click on it, will be loaded. You can see, click on here, and the custom, suppose I want to stress 98%. So now it automatically provide you the minimum and maximum value. So I can get from here. So now apply it, and further I just simply copy this value and paste here as a minimum value, and also copy this value as the maximum value. Okay, you can see in the rainy season we can get the very high positive 0.5, and the dry season we can get the 0.1. Okay, so now I want to click to the run. So now it visualize the two NWI maps in rainy season as well as also dry season. Okay, we can get this type of map. We can see. Okay. In this time, we can see this type of map we can get from here. One is it's a rainy season, as well as also you can see it's a dry season. Okay, it's a dry season. You can see there is no water body in here. Also, you can see there is no water body. But when I open that, you can get this is the water body. Also, water body. Also, you can get the water body. Okay. So if you want to check the value, suppose I want to check the value. Suppose I just click on here. Just click on here. Inspector tab click, and I check the pixel value of NWI for both of season. Click on here. Here you can see we can get this type of value. Here you can see the NWI for the dry. For the dry, there is no water, but in the rainy season we find out the water. Okay, mainly negative pixel value, there is no water, but in the rainy season we can find out the water 0.5. Also, suppose I click on here, then check what happened in here. In this time we can get the, you can see negative value. Okay, negative value means that there is no water, but we can get the rainy season, we can get the positive value 0.5. It means that in the rainy season it will be water, but dry season there is no water. I also check other, suppose I just click on here. So you can see in this time I can get the very low value of positive in the dry season, but rainy season you can see we can get that high value than this value. We can get the 0.5. at the 0.06, very low value. We can get the 0.5 in here. Okay, so in this time, we can easily identify about the pixel, but in this time, I want to monitor the rainy season water. Okay, suppose in this time, I can get the two map, rainy season EWI map and dry season EWI map. So now from here, I want to extract only for the rainy season water, rainy season or extra water. Okay, for that, suppose I click on here. So in this time, you can see what the value I can get. In this time, I can get that in DWI dry season 0.1. So basically, in this time, I will show you that how we can easily apply the thresholding, okay, and extract the water body. Okay, for applying the thresholding, first of all, you have to check any permanent water. Suppose it's a permanent water body. Okay, so for that, suppose I click on this lake and then find out what's the value we can get. In this time, I can get the value. You can see in the dry season, we find out the 0.1, and the rainy season, I find out the 0.3. Okay. Suppose I click on here, then you can check what happened. Okay, just you simply check some value, and then depend on your value, you put the thresholding technique. Okay. So in this time, you can check. You can say I can get that 0.07, and I can get the 0.5. Also, when I click on here, you can see in this time I can get that 0.1. Okay, and in DWI 0.3. Okay, suppose in this time, based on this pixel value, I just apply the thresholding. So how I can do that? So for that, I just take a variable. Suppose I put the variable name is a suppose wet season water or rainy season water. You can put suppose wet season water. So for that, first of all, I consider NWI wet season. Okay, so basically NWI wet season means rainy season. I simply call that NWI rainy season. I consider all of those pixel greater than 0.2. Okay, all of those pixel greater than 0.2, and all of those pixel NWI mainly dry season less than 0.2. Okay, so in this time I consider all of those rainy season or wet season greater than 0.2, and all of those dry season pixel greater than less than 2 I consider as a wet season water. Okay, and for that, how we can set this value? Basically, this value is not fixed or is not constant all time. You have to check sometimes. Suppose in this time here you can see less than 0.2, all of those dry season less than 0.2, and all of those pixel for the rainy season greater than 0.2. You can see here. Suppose I just click on here. In this time I can get I can get the greater than 0.2. You can see I can get the 0.4. Okay, I must always I can get the 0.4, and also you can see I can get the less than. You can see it's the 0.2. We can get the less than value. All time we can get it. Suppose I just click any water body. Suppose I click on here. In this time you can see I can get the greater than 0.2. Okay, it's almost 0.2 same. Okay, but in this time also you can see negative 0.4, which is the less than 0.2 for the dry season. Suppose I click on here any other water body. In this time, we can say I can get the value 0.5, which is greater than 0.2, and we can get the dry season. You can see negative 0.2, which is less than 0.2. Okay, so according this condition in this time, I said it's my wet season water. Okay, so all of those pixel which is greater than 0.2 from rainy season water, and all of those pixel which is less than 0.2 from dry season water, I consider it's a wet season water or rainy season water. Okay, so now I want to show the only according this condition which pixel I want to display on my map. Okay, so let's go for displaying this map. I just take a variable, suppose water max, and then wet season water And this wet season water I will need to update max with this condition. Okay, with this condition I need to update max with this condition. And what is my condition? My condition is the wet season water. I simply copy and paste here. Okay, so now let's check about this result. So just I use here the map dot add layer, and I want to display the water max, and then water max. I want to show the suppose plated. I want to show the all of those pixel as a suppose just I put the plated as a blue. And now click the run. Now check what happened. It's loaded. Just I open the first layer. I remove this. Okay. So now we can get this type of water. We can find out in the rainy season. Okay, and this condition is that all this type of pixel condition is that from the rainy season greater than 0.2, and from the dry season less than 0.2. Between this condition we can get this type of water pixel. Okay, if you want to check it, suppose I just click on here. You can see that result less than 0.2 and greater than 0.2. Okay, greater than 0.2 you can get from here. Now we can get this type of value. Suppose I click on here. You can see less than 0.2 and greater than 0.2 for the rainy season. Suppose click on here. You can see we can get the less than 0.2 from dry season, and rainy season we can get that result greater than 0.2. Okay, so basically this is the way, and this type of thresholding technique also used for flood mapping. Suppose you want to make the flood mapping using the SAR image, or just you want to identify the water pixel for the before and after condition of the flood, and then use this type of thresholding technique, and then you can easily identify for flood mapping. So it also used for the flood mapping. So in this time, suppose I want to calculate how much area is available for this condition. Okay, I want to calculate the water area. Suppose how much area is available for this type of water I want to calculate. So for calculating this type of things, we are just calculate different way. We can just calculate the pixel area, how much water area is available. Okay, so for that, when you calculate any kinds of pixel area, then we have to use the function dot image dot pixel area. Okay, so basically this is the function dot image dot pixel area. This function all time when you calculate any raster image, then we just use here dot image dot pixel area, and we can get the result in square meter unit. Okay, when you calculate this function using this function, we get the result in square meter unit, but we can easily convert into square kilometer or square or hectare unit. We can easily convert. So now how I can calculate the area of the water pixel or water max, how I can calculate the area. So for calculating this area, suppose I just give a variable name. Suppose I put the name is that area water. You can put any name. I put the area water. Okay, and then call the water max, because this variable is stored this type of pixel. Okay, stored this type of pixel. So just I simply paste here, and then further I just multiply. So just use here the multiply function with my ee dot image dot pixel area. Okay, this function is simply multiply. And now I just use a function, this function called the reduce. In this time, suppose any one raster or any one image, in this time you can see this layer. This layer is stored this type of water pixel. You want to calculate the water area. So just I simply call this variable name, because this variable is stored this water area or water raster image is stored in this variable. I simply copy and paste here, then multiply with this function, and then use the reduce region function. Okay, and this function calculated the result as a square meter, but when you want to show the value, you compute the value, then we have to use the reduce region function. Okay, and reduce region function calculate the statistical number. Okay, in this time I want to calculate the total number of area. So for that I just simply put all of this argument one by one. Okay, just put one by one. I just make a dictionary. So curly bracket start and also curly bracket end. You can see the reducer. So reducer is the statistical argument. In this time I want to calculate the total area. So just use here ee dot reducer dot sum. Okay, it means that total. Then geometry. Geometry mainly your specific boundary, your shapefile. In this time here you can see my shapefile variable name is that ROI. So just I put here that ROI. Okay, it's done. Scale. Scale is the resolution of your satellite imagery. In this time where you use at the mainly you can see here about the resolution of your band. It is a 10 meter. Okay, 10 meter green is the 10 meter. Also you can see near infrared band is also 10 meter. So just we can easily use at the 10 meter resolution as a scale value. Just put it at the 10 meter. And CRS not need, I simply remove that. It also not need, remove. And then further I just print that. Okay, simply print. Is area water, and then click to the run. So now it displays the result, how much area. So here you can see we can get this type of area, and you can see here all time when you are use the reduce region function, we get the result as the object, mainly dictionary. Okay, so here you can say I click on here, I can get the keyword and key value. Okay, it's called a dictionary, keyword and key value. Reduce region all time provide you the result as a dictionary, and here we find out the keyword and key value. ND is the keyword and key value is that the number result, and it show the square meter unit. So now I want to convert it into suppose square. I convert hectare. I want to convert the hectare or square kilometer. Anyone, you can do anything. So for that, first of all, how I can convert the unit. So for doing these things, just take a variable name. Suppose I put the variable name is that area, and you can see it's a number. Okay, in Google Earth Engine platform, when you construct any new number, or when you want to store it any new number in a variable, you must use a function, this function called ee dot number. Okay, and this number is stored in a variable, this variable called the print area water, sorry, area water. Simply copy and paste here. Okay, and you can see here this number get from ND. Okay, ND is the keyword, and ND, this number get from ND. So for that you can use a function, this function called the get, and get then put here the ND. Basically this ND, this keyword, simply put here the ND, and then further I want to convert into a square meter to hectare. Okay, for a square meter to hectare, when you convert, just simply multiply 1 into 10 inverse 4, or the scientific notation 1e inverse 4. Then we can get the result in hectare unit. Okay, so now I simply print that area and click run. So now it calculate the area, how much water in the in the rainy season we can got. It show the result. We can see we can get the 1474.03 hectare area. If you want, you can also use a function. Suppose you need only for the integer value, so you can easily use a function. This function called the round function, and then click to the run. In this time, we can get the result and as an integer number without double or floating number. We can get the 1474 hectare area. Okay. So in this time, when you have any question, you can ask me. Any question or any doubt for the whole code. And this technique you can also use for monitoring the flood region as well as anything, any thresholding technique. In this time, I show you for the only for the NWI. But if you want, you can also use for that extracting the vegetation area as well as also extract the forest area. Suppose you are just calculated the NDVI, and then from this NDVI you can easily calculate or identify it's a dense forest. And this thresholding technique, there are a lot of uses. If you want, you can also use it to identify for the cropland. Okay, there are a lot of use for the thresholding technique. For that, you are just use it, it will be okay. So in this time, when you have any question or any doubt? Okay, okay, I think there is no question. Okay.
No, sir. No, sir.
I also send you this code, you also try to practice. Okay, so in this time, I talk about the time series chart. Suppose for this, I want to observe what is the condition for temporal time series chart of NDWI in the dry season and rainy season. Okay, I want to make the time series chart and then identify for the temporal changes of NDWI. And we already know about the one kind of information, ready-made data set and unready-made data set. So mainly ready-made data set is already available. The band such as NDVI band or NDWI band is already available. But this type of things here you can see there is no band about the NDWI. In this time we are create the band of NDWI. Okay, we create the band of NDWI or which index you need the time series chart. Just calculate this band. Suppose in this time I want to make the NDWI time series chart for rainy season. Okay, so for that I just use the rainy season image and then further I just create the band of NDWI. So in this time you can see when I print that, suppose I just print this image. So print this rainy image and then click to the run. You can see there is no band of NDWI. You can see the band list. There is no band about the NDWI. Okay, so there is no band about the NDWI. So in this time, anyhow, I need to create the NDWI band. And when I can create this NDWI band, I can easily make the time series chart. Okay, so let's go how we can easily create the band. And it's also very important for that creation of the band, because when you want to make the land use land cover classification map, when you input different types of band in your model, then you also need to create the band. Okay, so in this time I'll also show you that. But when I work with the land use land cover classification, then I also try to show you that how we can easily create the external band such as NDVI, EVI, or SAVI. So this type of band, how we can easily create and then apply in our machine learning model to predict the land use land cover classification or make the land use land cover classification or change detection. Okay, so that's why it's very important for create the bands, how we can easily create the band. For creating the band, first step is that you have to create a function. Okay, step one, create a function. Okay, so in this time, just create a function. We already know about the function structure in JavaScript programming. So just we are applying. Suppose take a variable name. I put the variable name, suppose add NDWI, and then put the function and put the element name, suppose image, and put the curly bracket. In this curly bracket, I put my argument. Okay, So this is the basic structure about the function in JavaScript programming. So in this time, my argument is that I just use this image and then calculated the NDWI. And then this NDWI I want to use as a band. So for that, just take a variable. Suppose NDWI. I use this image. I simply copy and paste here. And then further, just use the function. Suppose normalized difference between two band. One is the band 3, green band, and another is the B8, near infrared band. Okay. So in this time, it creates this band. This is my equation. I just put in here. And now what I return from here? I want to return as a band. So just use here the return function. Return this image add bands. And what is the condition about that? This condition is that these things I simply copy and paste here. Okay, so this is the way for creating the band. Okay, so in this time here you can see I just take a variable name and then use here the equal sign and call the function, and I use the element. Okay, so now I want to use this element as the image. Okay, and further I use here the curly bracket, and in this time here you can see in this curly bracket I want to find out the NDWI. I give a variable name and then use this element normalize difference, and then put here that my mainly it's a green minus infrared band, and then this image, this element I want to return add bands NDWI. Okay, so now I just try to suppose rename as the NDWI. Okay, just I put the name about the band name. Okay, or if you want, suppose without what I can get, you can check. Suppose without that, we can get the default name. Okay, so in this time, this is my function, and this function I need to connect with my image. So here you can see this is my image. So just I simply this is my image. Okay, so just I simply copy the full things from here, copy, and then paste. Okay, so this is my image and this is my function. Okay, I want to connect this function with my image. So how I can connect? Very easy. Just you can use a function. This function called the map function. So just use here a function. This function called the map function, and then call this function variable name. Simply copy and paste here. Okay. So in this time you can see what happened. Click the run. In this time it added a new band. This band name is that ND. You can see it show the 23 and now it show the 24. So click on here, you can see it added a new band. It's called the ND, but I want to change the name. So for that you can easily put the rename function. Okay, just put here the rename. I put the name as the NDWI. So click the run. So now it create the NDWI. So here you can see it show the name now. It show the name is that NDWI. Okay. So now it create the band of NDWI. Okay. So basically this is the process for creating the band, and this band also add with your image. Okay. This is the process. So now you can easily use this NDWI band and also visualize this map, as well as you can also make the time series chart. Anything you can easily do. So in this time, I will show you that how we can easily create the time series chart of NDWI in the rainy season. Okay. So for doing these things, so let's go. So for doing this time series chart, suppose I just use a function. This function called the UI dot chart dot image dot series. Okay. So this is our function, and this function we are used to make the time series chart. And what's the first argument? You can see first argument is the image collection. Okay, but in this time this variable is stored only for the one image. Okay, you can see only for the one image because I use at the median. Median means that it make the median one image. All of those image use and the create the median image. Okay, so it's not an image collection. It's just a single image. And for the single image, it's not possible to create